what we're about to cover today is super duper important, one, to CSC 116, and two, your entire career as a computer science student. GitHub is used for literally every project and assignment that you'll have here. And then some of the concepts that we're actually going to go over today, like branches, are not covered until your junior year officially. So we're gonna give you some little things that'll help out a ton in your NC State classes. And so the first step is we are going to download a program. I didn't ask you guys to download this program beforehand because the setup process we've had issues with in the past. So we're just gonna download it all together, and it should take hopefully like maybe 5 minutes or so. So if you go to gitkraken.com/download, so yeah, just download GitKraken setup, and then when it's finished, run the setup executable so it can install and launch GitKraken. So for those of you who GitKraken has installed for, you should see a window asking you to sign into GitKraken. Select the sign in with GitHub option and then follow the validation prompts. So you sign in with your personal GitHub account. Do not do this with your NCSU account because NCSU does some weird stuff with GitHub Enterprise, and we're not about to mess with that. So we're going to take a small break from GitKraken so we can talk about GitHub.
Okay, what is GitHub? Well, GitHub is a platform that helps people solve problems by building software together. So, how does it work? This is Sam. Sam works on tractors all day, but not in the way you might be thinking. She builds the software that helps make tractors more efficient. And she does this on GitHub with the help of her team, VJ, Melinda, and Mike. Now, even though they all work on the same project, Sam and her team don't all work in the same part of the world. This is Eddie. Eddie also works on tractors all day, except he actually works on the tractors all day. And this is the Harvester L700. It's the latest flagship in the company's fleet of tractors. It's full of sensors and processors that produce a ton of diagnostic data. Eddie has a great idea for how farmers might share their data and improve their harvests. So Eddie opens an issue on GitHub. Issues are discussion threads where people can report bugs, request features, or even just ask questions. Sam is the first one on her team to see Eddie's issue, and she thinks that VJ would be the best person to start the job. And here's where we get into the nuts and bolts. Eddie isn't the only person using the Harvester L700. All over the world, other tractors are collecting moisture data, and they need to keep running smoothly even while VJ is working on the new features. He needs a dedicated place to experiment so none of his changes end up on the farm before they're ready. So he creates a branch of the code, an alternate timeline where he can safely make changes to the software. Now he's ready to start writing the new feature. GitHub tracks VJ's changes and saves snapshots of his progress. When he's ready to collaborate on the changes with his team, he opens a pull request on GitHub. Pull requests let you show others the changes you're proposing so they can review and discuss them. This means VJ's teammates can help with roadblocks and even make improvements. On GitHub, everyone has a copy of the project. So if Melinda has an idea for something that will help make VJ's work even better, she can add it to the branch herself. GitHub keeps a record of everyone's contributions and feedback in the pull request, alongside relevant messages from the team's other systems. Once the team has signed off on the changes, VJ can incorporate the new code into the project. The new feature will be available to everyone as soon as he merges it in. Now farmers everywhere can all benefit from Eddie's great idea. But this is really only the beginning of the story. Because GitHub is the largest community of developers in the world, with millions of people sharing their projects, Eddie's idea could end up helping people in unimaginable ways. What kinds of problems are you trying to solve? Whether you're an engineer, a code enthusiast, or even a farmer trying to harvest grain, software touches every corner of our lives. GitHub is where people build that software. It's how they build software. Together.
So that's like one of the most informative advertisements I've ever seen. And I'm pretty sure they even show that to us in some of our classes. So just wanted to show that. The two big takeaways from that that actually relate to you developing games is that it allows you to periodically save your projects online. So that way, if you do mess something up, you can always undo it. And also, if your computer ever dies, then your project is still safe. And also, multiple people can work on the same project, which allows us to form teams and actually work on games together. And so a little bit of terminology. The repository is the entire project. Every single file that gets uploaded to GitHub is in the repository. And then if you look over here, this is the repository that we're going to be using for the workshop today. This is what it looks like on GitHub. Branches are different versions of this repository, and you can, just like in the video, edit them without affecting all the other branches. And you can see on GitHub here, I have a whole bunch of branches, and then each one has its own stuff inside of it. And then the way that we've historically split up branches in VGDC is by developer and or the feature. So like when I had to make water for one of our VR games, I made a branch that was called like water cups. And then I did all the stuff in there, and then I just merged that back into like the main development branch. And then typically master is the name of like the main branch. And you always want to make sure that it's like the working product. You don't want it to have glitches or bugs or anything. You want it to only be like the main thing. So now we're going to use GitKraken to visualize our GitHub repository. First, we need to clone in the repository, which means we need to put it on our computer. So if you click the folder in the top left of GitKraken, it'll open up the repository management window. If you open up the clone tab and then you pick clone with URL, up here you select the location that you want it to go to. I would recommend, just for this workshop, doing it to your desktop so you can access it easily. Pressing browse allows you to figure out exactly where you want to put it. And then for the URL, if you go to the repository, there's this little green button that says code. And then there's a link in here. This is the link you want to put in there. You would put that in there, and it would show you the full path to your repository, and then once you press clone the repo, it should open it up in GitKraken. I've already cloned it, so I'm not going to press that. I'm just going to open up the repository. This is the repository. In the center here, you see all of the different branches of the repository. You view where they branch from, and then even where they merge together. Like right here, you saw a couple of branches branched off from master at the front, and then I did stuff with them, and then they merged in later over here. You can check out different branches by double-clicking the name. So like Joseph/note, if I double-click that, I am now inside the note branch. So if I bring over my file explorer, if you want to see like all the different files in a branch, open up File Explorer and then just kind of watch them change as you go to different branches. So like Joseph/note has this note text file. Joseph/readme, if I open up the right thing, does not have it. You can check out and check all the different branches to see all the different changes between them. And then a little bit more terminology. Local branches are the branches that you've saved to your computer. So I've opened up Note and README and Master on my computer. So those are all local branches that I have right now. You can see them all in the local section up here. Remote branches are all of the branches as they currently are on GitHub. And you can see them over here in the remote tab. If you click origin, if it's not showing up yet, you'll see all of them right here. And so then once I go to one of them, like Git Ignore, it's now in my local branches because I've saved it to my computer. And then another little tip, if you ever have too many local branches and it's just a mess, you can remove local branches that you don't need anymore. by right-clicking in here and then doing delete. And then deleting doesn't remove it from GitHub, since you're deleting it from the local. It just deletes it from your computer, and then you can always re-download it back to your computer. And so right now, just spend a few minutes checking out the branches that are already in here. Open up the repository in File Explorer to check out all the files. So right now, I'm going to need everyone to put their GitHub username in the chat, so that way we can add you as a contributor to the repository. This will allow you to start editing it when we do our second part of this workshop. Cool. So now we're all going to make our own branches. If you check out the master branch, you can right-click it and then select create branch here, and then you enter a name. Now, good source control practice is to make a branch with a following the project's naming scheme. So the naming scheme that I kind of started with this was my name / the feature name. And so if you want to help out your fellow developers, you should probably do that. So like I did Joseph / branch 1. And then I have my own branch. And then once you've done it, you should see it pop up. It pops up in your local tab and it's highlighted green, which means that you're currently checked into that branch. And so now we're actually gonna do some stuff in this branch. So I want you all to add some type of file, either a text file, an image, or something else that's small. So me, I'm just gonna do new text document and be like, ayo. And then if you want, you could add stuff in it. And then once you've added it, you'll see on the right-hand side over here that the file pops up in your unstaged files. Staging is when you select a file that you want sent to the remote version of your branch. So if you do stage all changes, which is what you normally will do, that'll put it into the stage files section. This prepares it for committing. Committing is when you package all those files with a message, so that way they're ready to be pushed up to GitHub. And so you want the commit message to be descriptive. So I would do like added ao.text. And then you can even give a description if you wanted to, just like further elaborate. I wanted to AO. And then you can press commit changes to one file, or however many files you have. And then that creates the commit. But it's important to note that while it's now up here and you've committed, it means that you've committed to your local branch. So this thing currently isn't on the GitHub website. And you can see that if I go to like the repo on the website, under here, there's no AO, or there's no Joseph / branch 1 branch. And so what you have to do now is you have to press this push button. Push is what happens when you send all of your commits to the remote branch. And so now, if I was to go back to the website, my branch 1 pops up. How do we add again? You add, so if you go into like the file explorer and you go into your repository, then just add a file there however you want to. You can copy in a file that already exists on your computer. You can create like a text document, just whatever you do. And then it'll pop up in your unstaged files up here. And then let me do that real quick so I can give an example. There we go. You can see view change. It's in the unstaged files. You can stage it and then just follow through. So commit message and commit. And then, so once it's been pushed up and the branch becomes a remote branch, other developers are able to access it. So like I can see, I think that's Luke, has pushed his branch up. And so now I can see the thing that he added in there. So top menu.png, Or, oh, can I? Yeah, there we go. I can view the top menu that he put in there. This was not the view I wanted. There we go. We're just gonna bring that. You know what? Let's work on this because this is one of the errors that's interesting. Okay, sending a screenshot. Cool. Yeah. If something just doesn't work, just kind of like close GitKraken and reopen it. Since GitKraken is like basically just a UI intermediary for all of the Git processes, sometimes it just doesn't work quite right, even though everything is perfectly fine. And we'll be going over later on how you can kind of like just go right into Git and not go through the UI. We just recommend GitKraken because look at all this beautiful lines that you can see. So now that we've all gone through the whole commit and push process, let's talk about merging. So now I want you to create another branch from, and let's get a little fun with this, any other branch in the repository. Then try merging your branch into that one. And so you can kind of see, I've done that earlier before we even started the workshop here, where I made, oh, well, now it's definitely going to be weird to show, but I made like a branch over here and a branch over here, and then they kind of merge together right in here. And that's where that merged branch is.
How are you seeing the branches? Because mine just are all in a list without the visual there.
So is it the list like really colorful, like kind of how mine looks right now?
Yeah.
So if you go right here, you can actually drag to like expand it.
Oh, okay.
Yeah, it collapses the whole thing. Oh, I guess I didn't explain how to merge. So once you have your second branch, go into, check out the branch you want to merge into. So the one that will be updated with all the stuff. So like for me, that's merge test. Then select the branch you want to merge into that one. So that one will be, let's go with merge, terrible naming scheme. But so now if you right click the one that you are merging the stuff from, it says merge Joseph/merge into Joseph/merge test. And so that kind of brings the two branches together. And you can see that right there. I have two branches here, merge x1, merge x2. If I want to bring merge x1 into merge x2, I want to check into merge x2 and then right click merge x1. And then is it in here? Is it not in here? Okay, so it doesn't appear if you do it like in the locals tab right there. You have to find the branch wherever it is. I guess I have it right there. You can drag into another. Oh, can I? Saying, do you want to merge? Okay, well, that's cool. According to Jack, you can drag one branch into another on the left side. It's not working for me, but it might work for you guys. I guess what I'll do is I'll just kind of merge, I'll merge Will's branch into mine. And so if you right click the branch you want to merge from, you will see merge that branch into the branch you're merging into. And then you click that and then it goes in there. Do the two branches that are being merged have to be pushed? At the very least, they both need to be local. So like at the very least, you both need to have, you need to have both of them in your local system fully updated. I would recommend pushing them though, just in case. So the beauty of doing the naming scheme that we chose is that GitKraken automatically puts them in folders. So like I can just see Ethan and then look at his branches. So pull requests are super special merges that you don't want to break everything. And so you have a pull request to get other people to approve your changes before it actually goes into the branch that you're merging into. So what I'm going to do is, well, actually, hold on. Sure. Josh already spiced up the README, and so he submitted a pull request. So I'm gonna just look that up on here. Hey, Josh, is this cool if I approve this?
I think that is recommended.
In that case, you can set the number of reviews required for each repository when you do a pull request. I set for this repository the requirement to be 6. So I'm gonna need 6 people to approve this so that way it actually gets merged into master. You can approve a pull request by, I think you actually you have to open it up on GitHub. So if you go over to where it says pull requests over here, and then the 3 dots, and then view pull request number 2 on github.com, you can check it out and then approve it. Typically, I do my pull requests on the website itself, just because it gives me access to more stuff. You can assign people to review it. You can assign people to like actually approve it. So if you know like, oh, this person would be a great person to like actually check if I did things right, you can give them their, you can assign labels and all this other stuff.
If you go to the, there's one section where it says review required, which I think's at the near the bottom of this page. It says like there's reviewers, show all reviewers, and if you haven't approved or can approve, I think it when you go there you're able to comment and then also either approve it or not approve it.
Also, you can leave a review and approve it from the commits page. Like if you, when you actually look at the commit, there's a little button that says review changes.
Okay, yeah, this is different. They used to have a review button at the bottom of conversation, and I don't know why that's not there anymore. But cool, so that's how you would approve it.
Yeah.
Awesome. So that was the process. Now it's been merged. So now we can go into pulling. You can see that now master has been updated. And if you look on your local section, master should be in there. There's a 2 and then like an arrow next to it pointing down. That means that you're 2 commits behind it. And so you need to essentially update the branch. So if you check out master and then you do pull, you will now be up to date with the online version, the remote version of the branch.
What if I have an arrow pointing up?
That means you have changes that you need to send to the remote. So if you check out whatever branch that is for you, and then go through like the usual stage commit that means you've already commit those. Sorry, wrong explanation. You need to press the push button.
I think the arrow and the number is how many commits you're ahead of the remote branch, right?
Yeah. If it's pointing down, your commits behind, and if it's pointing up, it means your commits ahead. Pull requests are not only for the master branch. We tend to use them mostly for the master branch because you don't want to mess up master, but if you wanted to, you could do pull requests for any branch to anywhere. It's just like a fancy way to say, hey, this is important and we don't want to mess it up. All right, so Megan, you said it's not working?
No, I fixed it.
Okay, cool.
Just had to right click on it for whatever reason.
Yeah, it's so stuff like that is why GitKraken's a little iffy. And we'll be going over Git bash a little bit. It's going to be very brief when we go over Git bash, but that's a way to just kind of go straight into the Git. Cool. And then the last 2 sections for GitKraken, I wanted to cover Git Ignores. In the remote branches, there's this one called Git Ignore, and if you check out that one, you'll see that there is a .gitignore file in there. And then when you open up that, you see there's this thing that says ignored, and then there's an asterisk.txt. What a gitignore does, and it needs to be called .gitignore, not like gitignore.txt or literally anything else. It has to be like that. The file names that are listed here will be ignored when you're doing your commits. So asterisk.txt means that you will be ignoring every text file anywhere in the project. And so right now, if I were to make a new text file, and this is texty, it doesn't pop up in my staged things because the git ignore is kind of excluding it. And the way this is usually used in game development is when you make games and you have all of your asset files and you have all of your code and everything that's like important for the game, you also have a bunch of junk that is auto-generated when you start running Unity. And so that junk doesn't actually need to be sent up to GitHub because whenever like you're working with someone, whenever they open up a project file that you sent to GitHub, Unity is going to recreate all of the generated files. So you don't need to send the generated files with it. So the git ignore will usually, and I can actually give a small example with that. Food truck. The git ignore for like a Unity project will talk about all these different things that gets auto-generated. So like builds and Visual Studio files and meta files and stuff like that. So that way all that generated stuff doesn't end up going to GitHub. When you make a project repo, do the git ignore first because this thing doesn't work in reverse. And small anecdote, when we made Vroom Vroom Taco, we had a bunch of generated stuff and then we put in the git ignore. And so we spent a good like 3 hours nuking everything until finally the git ignore decided to work and everything was fine again. So now that we've gone over git ignores, now we're going to talk about breaking things. So when you are working with other people, it gets complicated, as you can tell from the rainbow that we see here. People working on the same thing at the same time will cause conflicts to occur when you start merging and putting things together. The most likely one that you'll find is a merge conflict. And so to demonstrate this, let me I'm going to just look at, where did I call it? What did I call it? Merge conflict 1 and merge conflict 2. So if we look at merge conflict 1, and then we go to my desktop, and we go to the workshop repo, you can see that I have this text file called merge conflictor. And this text file just basically explains, hey, this is going to cause a merge conflict. And it says this line of text being added in merge conflict 1. We go to merge conflict 2, and then we open this up, and we look at merge conflictor. It's the same thing, except this is the line of text being added in merge conflict 2. Also, we're going to just remove that because that doesn't need to be in there. Cool. What will happen, since it's the same file, but there's one line different, when you try to merge merge conflict 1 into merge conflict 2, it's going to tell you that there's been merge conflicts detected. And then GitKraken allows you to actually see where the merge conflict is if you click on the file that has the merge conflict, and it highlights both. So I can see, okay, it's this one. And then there's solutions for this depending on what the conflict is about. So like, let's say the only thing that mattered was a merge conflict 2. I would choose to keep that and line 9. Oh, I want line 9 and then that, thank you. And then I could save it, and this thing basically just gets trashed. It'll still exist in the other branch, but for the branch I'm gonna continue working on, it's gone. But if both versions are important, what I recommend doing is just renaming one of these files, the merge conflictor.txt, make it like merge conflictor2.txt. And then you won't have the conflict anymore because they are considered different files. And then once all the merging has happened, you can just kind of mess with the files that were giving you trouble and it'll fix it. Or if you really want, you could have both of the changes in one file. And then let me check that. So commit and merge. So now this thing has merge conflict 2 and 1. That's another option. But the best solution to fixing a merge conflict is neither of those. Best solution is to prevent them from happening in the first place. If you communicate with your team and you make sure that you're not working on the same file at the same time on different branches, then you won't have merge conflicts. I say that knowing that you're still going to have merge conflicts because it never works perfectly, but communicate and they will be less. And then there's other stuff that's going to happen. And that usually happens, like let's say if I started messing around on Aaron's branch and I started changing his files. So I went into testing and I was like, hey, yo, pranks. And I started pushing my changes up to his branch while he's still doing stuff on his branch. There's going to be some conflicts. It's going to be like, yo, I can't push. I can't do nothing. And then it's just kind of, I would recommend just renaming the file. That's kind of like the catch-all fix for these kinds of things. Just rename the file, and then once you've pushed everything to GitHub, then you can work on fixing it. But once again, best solution is to just communicate with your team. If I had asked Aaron, hey, are you working on this file right now on your branch? And then he had said, no, I'm not, then there's not going to be a conflict. Yeah, it's less stressful when you don't have, I think there's like 17 people working on this. Usually your projects will look something like Meme Texter, which is like a group of 3 people. That was me, Bailey, and Will. And it's just kind of like you do one branch to work on something and they just kind of start merging into each other to eventually just be the final branch. So yeah, it's less spaghetti once it's not like this.